Alright, this video we're going to talk about exponent rules. This is what we're going to do on Monday. So with exponent rules we have, we're only going to do a couple of them today, 3 of them. There are going to be more. I do want you guys to write these down because they come up over and over again in Algebra 2. The first one is when you're multiplying the same base with exponents. So a base is, if I have something like 3 squared, 3 is the base. It's the part that has the exponent. So these rules only apply when the bases are the same. Meaning I have something like 3 squared times 3 to the 4. The two bases are the same, the 3 and the 3. So what this is really saying is 3 squared means 3 times 3. And 3 to the 4 means 3 times 3 times 3 times 3. So this is 3 squared. And this is 3 to the 4. So I would write this as 3 to the power of, I have 1, 2, 3, 4, 5, 6 of them. But mathematically there has to be an easier way, because if I have something like 3 to the 101 times 3 to the 205, I'm not going to want to write out this 101 times and this 205 times. So there has to be another way. So I noticed that this became 3 to the 6. And I noticed that the exponents were 2 and 4. So I say, oh, 2 plus 4 gives me 6. Which means base with an exponent times same base with an exponent. I'm just going to add those exponents together. So notice that on this, the base didn't change. The base still remains the same. And same thing here. So when I do this, it's going to become 3 to the power of 101 plus 205, which is going to be 3 to the 306. So that's how we're doing these ones when we're multiplying the same base with an exponent. Sometimes we'll get stuff that has multiple bases in it, like 3 squared, x to the 4, y to the 7, times 3 to the 5, x to the 2, y to the 4. Okay, if I have something like this, only the same bases go together, meaning the identity property of multiplication lets me put it as 3 squared times 3 to the 5th times x to the 4th times x squared times y to the 7 times y to the 4th. So all I'm doing is I'm rearranging them so that the same bases are next to each other, to make it a little easier on myself. This is going to become 3 to the 7 because 2 plus 5. This is going to become x to the 6 because 4 plus 2. This is going to become y to the 11 because 7 plus 4. So only the parts that are the same go together, and we change it up. So that's multiplying. Division is kind of the opposite of multiplication. So if I have something that tells me 3 to the 4 over 3 to the 2, this means 3 times 3 times 3 times 3 over 3 times 3. We know that these are going to cancel out because they equal 1. So it's going to become 3 to the, I only have 2 left. So there had to be an easier way to do that. So I noticed this is 4 and this is 2, and it became 2. So I'm going to do the exponent minus the exponent. So when I have the same base and exponents with division, I subtract the exponents. If I have something like this, becomes 7 minus 5 is 2. So that's how we're doing these. Now again, sometimes I'll have multiple pieces. Once again, only the pieces that are the same go together. So I'm going to do 2 minus 5 is negative 3. 4 minus 2 is 2. 7 minus 4 is 3. That's how we do those. The last one is when I only have one base, but I have two exponents. So what this means is anything to the power of 5 means it happens 5 times. So I have 3 squared 5 times. We already know when it's the same base with exponents, I add them up. So 2 plus 2 is 4, plus 2 is 6, plus 2 is 8, plus 2 is 10. There has to be an easier way. So I notice with 2 and 5, if I multiplied those, I would have got 2 to the 10. So if I have base with an exponent to the exponent, it becomes base to the exponent times exponent. Again, it happens to every piece that's there. So if I have multiple pieces there, every single piece is going to get it. So 2 times 3 is going to give me 6. 4 times 3 is going to give me 12. 7 times 3 is going to give me 21. And that's how we're doing these today.